Good afternoon and welcome to Writing Ratios as Percents, the first session in Unit 5. All right, so how do you use ratios to write percents and fractions? How do you use ratios to write percents and fractions? Remember, ratios is just a fancy word for fraction. So how do I use a fraction to create a percent? How do I use a fraction to create a percent? Well, we need to do a little bit of a review first. First of all, remember, always hit pause and come back again if you need to write something down and didn't have enough time. And also that you can rewind, I suppose, or go back and listen to something again if needed. So here we go with a little bit of review. I'm not going to click that while we're here. We'll just talk about it. Percent. Percent. Per 100. Out of 100. Percent is a ratio, a fraction, comparing a number to 100. Just like you would do on your test to figure out what percent you got on a test. Let's say that on a test there were 25 possible points and you earned 17 of them. What percent did you get? Well, I want to compare that to 100. In order to do that, I can try multiple different things, but I know that from my study of proportions and rates that I could take 5 times 4 to get to 100. So I would just be taking 17 times 4. And what would that get me to? 17 times 4 would get me to a 68. So what kind of a percent did I get on this test? Well, not quite the best I could have. But that's what I got. I got a 68% because I'm comparing it to 100. All right, so let's talk a little bit more about percents and see how we can examine some of this. Here we go. In a recent census, this is a little large, so we'll shrink it down a little bit. In a recent census, there we go. In a recent census, 26 out of every 100 people living in Illinois were younger than 18. 26 out of every people living in Illinois were younger than 18. So we have two questions to address here. Question 1, what percent of people were younger than 18? Well, this right here says 26 out of 100 were younger than 18. If I was to take my fraction, my ratio, 26 out of 100 were younger than 18, so 26%, because that is already compared to 100. The next question changes it up a little bit. What percent of people were older than 18? Well, if 26 were younger, we'll say what percent of people were 18 or older. We'll just change that. We're 18 or older. What percent would that be? Well, that would be whatever percent is left over to get me up to 100. So 100 minus 26 would be 74%. 74 out of 100 would be how many are 18 years of age or older? 74%. 26 were younger than 18. 74 would be 18 or older. And if I added those two up, they should equal 100 if I did my math right. Again, just writing a ratio as a percent is simply putting it over 100. Compare it to 100. All right, let's shrink this one up a little bit too. Don't know why all the sizing is off today. So I apologize for the work in the middle. At a local middle school, 140 students take Spanish for every 100 students who take French. 140 students take Spanish for every 100 students who take French. What percent of the students take French? All right, I know what this question is getting at, and so let's see if you can follow with me here. At a local middle school, 140 students take Spanish for every 100 who take French. What percent of the students take French? So I have a few things here. I know that there are 140 to 100. 140 take Spanish for every 100 who take French. That's a total of 240 students. 240 students. So then we need to ask ourselves, okay, if that's 240 students, the question says what percent of the students take French? Well, 100 out of the 240 take French. 100 of the 240 take French. So if I was to then figure out over 100 what this would be, I would do some cross multiplying here, and I'd get 10,000 up here. I'd get 240x over here. I'm going to divide both sides by 240. And I would get 41.6 repeating percent, because that's what that would fill in as. Now, what the question the book was getting at is what they wanted you to do is say, you know, what percent of them, they want you to know that percents can be more than 100. So they wanted you to see that some things might result in being more than 100. I think that a better question in this scenario would be related to a test, would be saying that you earned extra credit on a test. You earned 2 points extra credit. I'm just going to put EC for extra credit on your test. The test was worth, just for easy math, let's say the test was worth 25 points. You had a perfect score and earned the extra credit. What percent did you earn? Well, in this case, I had the 25 points for my perfect score plus the 2 points extra credit. So I received 27 points out of 25 possible points for the test. So what would my percent be? Well, I would compare this to 100, multiply this by 4, multiply that by 4, and I would get 120%. Hopefully I did my math right there, but I think I did something wrong. So no, it's not 100 per. What am I? 108%. Sorry. 108%. So, or 108 over 100. So I had 108% on this test. I had some extra credit. That, in my mind, that's what they were trying to actually get at, is so you could see the fact that you might have percents that are over 100. All right, let's look at this next one. Here we go. We have Dan Marino. Many of you football fans know the name, and some of you who may not even be football fans know the name. But Dan Marino, in his football career, completed a pass about 59 times out of every 100. This is an estimate. Some games are better, some games are worse. But this is what he completed. What is his percent for completed passes? Well, I know I completed about 59 times. So what are my percent? 59 over 100. 59% of the time, I completed a pass. It's that simple. There's not much more to that. About 1 out of every 10 Native Americans in the United States are part of the Cherokee Nation. What percent is this? 1 out of 10. So every one, there we go. Every 1 out of 10 is part of the Cherokee Nation. What percent would that be? Well, I need to compare it to 100 again. In order to do that, I multiply both sides by 10, and I get 10 over 100. Once I have my percent over 100, I know that it's 10%. 10% of the Native Americans were part of the Cherokee Nation. About 1/200th of the toys were defective, broken, not working right. What percent of the toys were defective? Well, 1/200th of the toys were defective. Remember, I want it to be out of 100. So how did I go from 200 down to 100? I divided by 2. So I'm going to divide this by 2. 1 divided by 2 is 0.5, or half. So what percent of the toys were defective? 0.5%, which is possible. I know it seems odd, but it's possible. How many toys were not defective. So you have two questions here. You need to be careful. This one says, how many toys are not defective? Well, if 1 out of 200, the 1/200th that we had, was defective, how many are not? Well, the remainder. The remainder that are not is going to be 199 toys out of the 200 are not defective. How many toys? Now this one says what percent? Well, if 5/10 or 0.5% was defective, what percent is not defective? All I'm going to do is take 100.0 and I'm going to subtract 0.5. Obviously I can't borrow some of these, so I'm going to have to, or take away from some, so I have to do some borrowing. 10 minus 5 is 5. So 99.5% are not defective. It's all about being careful, reading the words, making sure you see what they're asking you. All right, almost 3/4 of people who travel, buy tickets online. What percent of people buy their tickets at the counter? This is where they're trying to get you. What percent of people buy their tickets at the counter? If I'm at the counter, am I online? No. So if 3/4 are online, what's left over? 1/4 at the counter. So first we had to turn it into the fraction. Now I need to turn that into the percent. I know that the fraction is 1/4, and I know that I need to turn that into 100. So how do I turn this into 100? In this case, I can multiply both by 25, and it would be 25 over 100, or 25%. Some of you may have been saying, yeah, I had a quicker way. I know that that's 0.25, 25/100ths, which would be this. And to make it a decimal, that we moved it over, or make it a percent, I moved the decimal over twice, and I would get 25%. That's great. You're remembering the skills from our past lessons. So keep doing that. Go right on ahead. All right. We have a few ratios here. They're written in this form. Again, we can change it to the other form if we want, to 7/10. And I want to write that as a percent. Write each ratio as a percent. How do I turn it into a percent? Compare it to 100. 10 times 10 equals 100. Whatever I do to the bottom, I do to the top. 70%. 9/20, again, compare it to 100. How do I turn this into 100? Times 5, times 5. 9 times 5 is 45, so 45%. 1/50. How do I turn 1/50 into a percent? Compare it to 100. How do I get 50 to 100? Times 2, times 2. 1 times 2 is 2. 2/100, or 2%. All you have to do is just continually, over and over, compare it to 100. So what do I know about today? Well, let's run back really quick and check our essential question. How do you use ratios to write percents and fractions? So how do I use ratios to write percents and fractions? What would you do? Think about it. Compare, now I bet you're getting it, to 100. I may even set up a proportion, which is what we were doing, comparing to 100. Set up a proportion comparing to 100. Percent is always over 100, and then whatever your fraction would be here, whether it was the part over part or part over whole. All right, thank you for checking in today. Hopefully this helps you on your assignment.